Let's do that one. That one, you don't need z-score. Forget z-score, screw it. Z-score is so like 2010. We use z-score for other things, but not for this anymore. Okay. All right, so let's go back here and let's do an example. So body temperature of a healthy probably kids as well, but adults' health data in general are more stable. So let's just assume adults. So body temperature of healthy adults are normally distributed with a mean of 37 degrees Celsius and standard deviation of 0.4 degrees. So question A. What kind of temperature would make you worried you have a fever? That's not question A. That's just my question right now. I mean, 40, 41, you're really worried, but what else? Okay, so what would all these people give me answer in degrees F? Do you guys measure your temperature in Fahrenheit or Celsius? Are you guys living in the same country? So if you go to the doctor's office and they take their temperature, they give you an answer in Fahrenheit or Celsius? Very interesting. So your height is measured in feet and inches. Your doctor gives you your temperature in Fahrenheit.
It's not a matter of doctors,
but they give you your weight in kilograms. This is very interesting.
It's
All right,
actually
so let's change all of these numbers into Fahrenheit. This would be 98.2 degrees Fahrenheit, and this would be 0.73 degrees Fahrenheit. So let's go back to the messages and see when is it that people start to worry about their fever. So there are various degrees, 105, 104, 101, 102, 104. Let's do part A first. Would you recognize that this is a probability question? Yeah, because percent of people is the same as probability that it happens, right? So what percent of people win the lottery? Let's say 0.5%. Well, that's the same as the probability of winning the lottery is 0.5%, right? What's the probability someone is like this, has temperature above 102 degrees? Well, that's whatever the answer is, let's say 3%, then that means the probability of being that is 3%. So this is the same as asking for probability. Okay, all right, so let's answer this. So first we notice that it says normally distributed. So that tells us that the temperature is normally distributed with some kind of mean. And we look it up, it says 98.2, and some kind of standard deviation. We look it up, it says 0.73. And we're looking for probability. that the temperature is above 102. And for this, we use StatCrunch. So go ahead and switch to StatCrunch. You probably already have StatCrunch with country of the world. You don't have to close out countries of the world. You can do calculation while it's still on. All right, is everyone done with the notes so I can switch to StatCrunch? Actually, if you're not ready, say no, because I'm switching. All right, so here we go. Stat. By the way, you have all of this. I sent you the complete guide at the beginning of class, right? So this is in there somewhere. Stat calculators, normal. Stat calculators, normal. Click on normal. You click on normal, you get this this thing. You fill in the mean, 98.2, and the standard deviation is 0.73. By the way, up here, there's a thing that has two different button, standard and between. Right now, the default is standard. And now you want to change this into the symbol we want. And the symbol we want is this symbol. Right? We want the probability that the temperature, which is X, is greater than 102. So we know this number is 102. And we want the greater than symbol. And it's not there. There's a less than or equal, and there's a greater than or equal. It doesn't have greater than, but it's okay. Right before the break, we realized that greater than or equal and greater than are the same for normal distribution. Be careful, that's not the same for other distribution, right? Just normal. So we change it to greater than, and it gives us an answer. The answer is some tiny probability, 0.00000001. It's very, very rare that someone that's healthy would have temperature of 102. That's why when you have 102, you worry because you're no longer healthy, right? So so going back to our notes. So we use StatCrunch, and the way you use StatCrunch is stats calculators, normal. We fill out the mean and standard deviation. And we want this. And then it gives us the answer. I think it was how many zeros? 4 or 5 zeros? 1, 2, 3, 6 zeros. All right, so let's do part B. Find probability temperature is less than 97. So go ahead and do that and put your answer in the chat box. Okay. Many people got 0.05. Oh, it's convenient that I have the mean and standard deviation already filled in. All I need to do is change this and change this, and I get the answer. And you see this area here, right? It's an illustration that says this red area is the probability. The 97 is the cutoff for that probability. And this number is that probability. That area is 0.05. Yeah. So where was the other number? Where was the red area when we were doing this? How come there's no red area? Well, yeah, first of all, it is negligible. Yeah. And also it's way far to the right. Right, 99 is here, 100 is here, so 101, 102 way out here. But yeah, when it's negligible, it won't show on the graph, right? So it will happen several times in this class where we do some calculation on StatCrunch. We expect some red area, and not just for normal distribution, but many other things. We expect a red area and we don't see it. And that's because it's so small. Yeah, it's negligible. It couldn't be shown. But anyway, right now our question is less than 97, so it's 0.05. Zero 0.05 01, so 050. In this class, let's standardize doing probability at 3 decimals. Okay, let's do one more. It's a little bit different. If you don't have a fever, what kind of temperature is not have a fever? Well, let's say that when you're 90, when you're 100 degrees Fahrenheit, do you worry? Up here, I have people saying they start worrying at 101. But if it's 100, are you worried? Nobody cares. So, so yeah, at 100, we don't care, right? At 101, we care. So I guess the cutoff, let's pretend that it's 105. A normal person would have temperature less than this, right? But obviously, we're not going to go all the way down, yeah? Because at some point, our temperature is too low, it's not normal. Let's pretend that we're going to start worrying if our body temperature goes all the way down to 296. So let's calculate that probability. What is the probability that the temperature is between 96 and 105? Well, mathematically, if you're in between here, if you're in between 100.5 and 96, that means there's a less than or equal in between them like that, right? So we want this probability. You get one number, and then you do the other one, you get another number. Well, what about, but we need just a single number, right? So yeah, you can work at it and do some algebra, but how are we going to put x in between, what did I say, 98 and 100.5? Because it's not in here. Well, and then you realize that up here there's a word that says between, right? So when you need something between, you click on between. Then the input changes. Now you can just put in the numbers. And then you hit compute 0.607. Was it 98 or 97? Oh, 96, sorry. 96. 0.998. And then the answer is 0.998. And it's like this. 96 is here, 100.5 is here. Down here is 0.998. That area is 0.998. But D. If I take the normal curve and I ask for the entire area of the whole normal curve, going all the way to infinity and negative infinity, what's that area equal to? That says 1. Any other answer? It says 0, but it can't be 0 because it obviously exists. Okay, so it's not going to be 0. Why is it 1? Okay, but why is it 1 and not some other number? That area contains everything, the whole population. So 1, because this is the probability of everything. And the probability of everything is everything, right? Everything, everywhere, all at once, 100%. At the 5% of people, highest of people. Now let's draw the graph first. Before we mark the temperature and we calculate the area, right? Well, this one is asking for what temperature? And where's the temperature? The temperature is like here along the x-axis, right? So that means it's looking for a number here somewhere. And it looked for the 5% highest, so it's somewhere on the high side. So the question is for this temperature. And then we're talking the 5%. Where does the 5% go on this graph? It's on the right end, but do I put here or somewhere else? Well, let me scroll back up. The percent goes in the area, right? The percent goes in the area. Do you remember this this problem where we end up with an area on this side here, right? So the percent, and this is the 0.050, and this here is 97. Okay. The percent goes where it's red on StatCrunch. So the 5% goes here. So the area is equal to 0.05. Okay. Right. So keep this picture in mind. Actually, you have it in your notes, right? So look at your notes while I switch over to StatCrunch. First of all, we're not in between situations, so it's standard. I'm going to move it here. All right, now, what is it that we don't know? We don't know this number, right? The temperature we don't know. So we're going to erase it out because we don't know it. We're on this side, so are we on the greater than side of things or on the less than side of things? This area. Is the area on the greater than side of things or on the less than side of things? It's on the greater than side because it's on this side, right? All these axes are bigger than the question mark. So I'm going to change this to greater than. So I don't know the temperature, but I do know the area. And if let's actually go back to this question. Part B. Part B, we did this, right? Less than 97 is this area, and this area was 0.0501, right? So now if we want to be greater than something we don't know, and we want that area to be 0.05 exactly, we're going to type it in to this space. And we click compute, it'll tell us that the answer is 99.4 degrees. So this spot right here is, here's 99, here's 100, this is 99.4, and the red area is 0.05. So StatCrunch. So the idea is you figure this out, determine this. And you type in 1. In between the last two squares, you type in 1, StatCrunch will calculate the other. You type in the temperature or the number, you'll calculate the probability. But if you type in the probability and you leave the other number blank, it'll fill in. Okay, so depends on what the question is asking for. You determine what to type. So let me give you a hint. Percent probability, you fill in the P and StatCrunch computes the equal box. Whereas if you ask for the cutoff, if they use the word percent, if they use the word probability, ask for. Whereas if it's asking for a cutoff, percentile, quartile, or it verbally talks about the variable. So the part that we just did, part E, it didn't use the word cutoff, it didn't use the word percentile, it didn't use the word quartile, but it refers to the variable, it refers to the temperature, right? Then you fill in this port, and StatCrunch will compute, and the this one and this port. You have to fill in the direction. And StatCrunch will compute the last remaining blank. Okay, between those two blanks, you fill in one, it calculates the other. So let's just do one more, just for fun. Find the third quartile of temperature. Hint, the answer is 98.69. 692378. See if you can get that answer. 98.69. I see an answer that is 97.7, and that's the wrong answer. That's the first quartile. You got the first quartile. I'm not sure how you got 0.251, because the third quartile, when people talk about quartile or percentile, they're looking for the variable value, which in this case is the temperature. So the answer has to be a temperature. It cannot be a 0.25 something. 0 degree Fahrenheit is very low. It's like negative 20 Celsius or something. Very low. If it's human being is dead. Anyone else have a thought? That has a whole solution laid out. Okay, there are two different ways of doing this actually. So let's draw the box plot, because that's where we see quartile. If you imagine the normal distribution, then at the third quartile, then over here is 0.25 and over here is 0.75, right? So there are two ways of doing it. You can do probability that x is greater than some unknown number is 0.25, right? That will get you the third quartile. Or you can also do this. X is less than, right? On this side is the less than side. Some number is 0.75. So there are two ways of doing it. Okay? But as long as you imagine that wherever the quartile is where it separates the lower 75% from the top 75%. Yeah. has 1.18. I think you forgot to put in the mean and standard deviation. So if you leave the mean and standard deviation, you can do it. By the way, this is what you did. You did 75% here. And that's how you got the 97.7. But look at it, right? This one has 25% on this side and 75% on that side. That's a 2. And that makes it the first quartile, not the third quartile. Okay, we're looking for the third quartile. So yeah, you have to watch this direction, this greater than versus less than, right? So that's, you always have to watch that. And so yeah, be careful about that. And whereas if I do it as a less than right here, then I would get the right one. This one is a Q3 with 25% this side and 75% that side. All right, are we good?